Hello, dear students. Today we will start our physics first chapter of NCERT, and basically, we will cover the portion of NCERT here, and it will be like for CBSE board students, and the chapter of like electric charge and field will be helpful for them to prepare for boards. So yeah, let's start the chapter. The first chapter of your physics in class 12th is electric charges and fields. I will now clearly explain that what are electric charges and fields. So, let's start. Yeah. So, electric charges is what? Electric charge is the physical property of any matter that causes it to experience a force when placed in an electromagnetic field. So, it is written here. I will now tell you that what it actually means. Suppose that I have any particle like this. So if I place it in any electromagnetic field, meaning that if I have any field like this of electric field like E, and if I place it in this field, so it will experience any type of force either in this direction, in this direction. So this property of any particle that it experience any force, any kind of force, either it can be repulsive also or attractive also, or in any direction in an electric field. So it is the property of a what, that it contains a charge. It contains charge, so that is why it experiences any force when placed in a electric field. So electric charge is a basic property of any a particle or material that have a possessing that is possessing a like a attractive or repulsive nature of a force. So we will clearly see this in the further in this chapter, that what are basically electric charges and what are these types of charges. We have generally have two types of charges, which is what, first is your positive charge, and another is negative charge. Okay. And electric charge is a scalar quantity. Remember that it is a scalar quantity. Okay. Okay. Let's move further. I hope that you got that what is electric charge. It is a basic property of any material or particle. Like you have a mass is a basic property of any material. So similarly, that we can say that charge is also a basic property of any material or particle, which allows it to experience any type of like attractive or repulsive force when it is placed in an electric field. Okay. So let's move further. There are methods we have. I have already told you that there are two types of charges, that is positive charge and negative charge. An object can attain positive charge by losing electrons, while other can attain. So it is written here. You can see there that by losing electron, like if I have any particle, and if it has like electrons inside this, you know that it contains electrons. So if it has electrons in it, and if it is losing it, like if it has losing it, some electrons, so what kind of charge will it get? Because negative charge is missing from it. Some negative charge are missing from it, so it will get positive charge. So I can say that this particle is positive charge. Okay, of this object is positive charge. Similarly, if I have any object and I am like giving these electrons, or electrons are coming inside it. So it will gain what type of charge? Negative charge, because it has now excess of electrons. It has gained some electrons, so it has excess of electrons. So I can say that object is negatively charged. Okay. So basically, I have told you that the there are two types of charges: positive charge and negative charge. This is a one difference between mass and charge. That mass is not two types. It is a basic property, but it has no types. Charge has types, like it can be positive also or negative also. Okay. So we will see in further chapter that what are the differences between mass and charges. Okay. So depending upon the uh, charges and their configuration, the materials can be classified into two types, basically, that are conductors and insulators. Okay. There are semiconductors also, but we will see that in another portion. We will first see that what are the conductors and insulators. So conductors are what? Those substances which can be used to carry or conduct electric charge electron from point to other. They allow electricity to pass through them. So you know that in chemistry or physics, in earlier classes, you have learned that conductor have free electrons. Okay, it has loosely bounded electrons in the outermost shell, and it can be moved inside the material or object. These are free electrons in the outermost shell. So what can we inform from that? That conductors have excess of free electrons, or they can easily conduct electricity or heat also, and this is the property of conductor. And some examples are like you have conductors like aluminium, iron, copper, and silver, gold. These are examples of conductors. On the other hand, insulators are those substances which cannot conduct electricity, and they have not so much, or you can say that they don't have free electrons inside them. Or like if you see insulator, they have negligible free electrons outside the like in outermost cell. You can find only one or two electrons there, so they cannot be effective in conducting electricity or heat also. So insulators are poor conductors, or poor conductors of electricity. We can now uh, like uh, uh, we can differentiate conductors and insulators. The conductors are those objects which can easily conduct electricity, while the insulators are those substances which cannot conduct electricity easily. Okay. So, what are we have just now learned about conductor and insulators. So, I will now define you what is the difference between dielectric and conductor. Okay. So, dielectrics are what? These are non-conductors and they do not have free electrons inside them. Okay. And yeah, just a minute. Yeah. So that they don't have the free electrons inside dielectrics, and conductors you already just have known that they have free electrons. Okay. So we will see some methods of charging, like how to charge any object. Okay. So there can be many methods by which a particle can be charged or an object can be charged. These can be like conduction or friction method or insulation method, induction method. Sorry, and i- in this chapter, I will basically emphasis on induction method here. So I will tell you what is the method charging of method by induction. Okay. So the process of charging a neutral body by bringing a charged body, like if you have any neutral body that is not charged, it has equal number of electrons and protons. And if I bring any charged body like this, which has excess of electrons inside that, if I bring it near it, so what happened that the electrons here will move farther from it because they will repel this electrons, excess electrons. The electron will move here. So I can see that some excess electrons will come over this side, and this side will become positive charge. So now if now Earth is this with negative charge portion, this part if I Earth, so it will what it will create here a zero potential, and the object here become positively charged because the positive terminal is there, and this will become neutral because this is Earth now, and the object there it will become positively charged. So this is one method by which we can charge a body, and it is called charging by induction. Okay. Now we will see some basic properties of electric charge. What are the basic properties it contains? So let's start with first property. The first property of electric charge is that it is the additive in nature. Okay, like if you have many charges on available inside any space, just a second. If you have like a bunch of charges which contain Q1 charge, Q2 charge, Q3, so there is a method by which you can add them. It is additive in nature. You can scalarly add them, like you are adding plus 3, plus 2, plus 5. So you simply add that minus 3 if these are the charges. So if you have to find the net charge inside this space, you simply add them plus 3, plus 2, plus 5, minus 3. With the sign, you add them and you will get the net charge. What will come? 5 plus 5, 10, minus 3, it is 7. Okay, so net charge will be here 7. So this is what additive nature of electric charge. Okay. And second property of electric charge is that it is conservative in nature. Okay. So during any process, the net electric charge of an isolated system always remains what? Constant. That is, it will conserve. If you have like system of charges and you try to uh, like charge them or conduct them by conduction method, so what happened that total net charge what is there in both the objects, it will be like conserved. It will neither we cannot create new charge or not can destroy new charge. Okay, like if you have this two objects and it has plus 5 charge, plus 3 charge. Okay, so if I have to told that what are the net charges there, so the net charge of system is 5 plus 3, and it will be conserved. It will always remain 8. Okay, whether no external agent is there, and if they are interacting with each other, then the charge will always be 8. So this is what conservative nature of electric charge. Yeah. So I hope that you got this point. Two basic properties of electric charges I have told you. One is additive nature of electric charge, and other is conservative nature of electric charge. Okay. So now we will see the questions in the next like lecture, because we will first cover the theory part. Then in the next lecture we will cover the questions also. Okay. So let us move to the topic two. The topic two is here what Coulomb's law and electrostatic field. So first of all, I will tell you that what is Coulomb's law. Okay, it is a very important law, and basically it covers your all the basic concepts in this chapter. And Coulomb has given it with many experiments, and after specifying the practical results, he has given this law. So let us try to focus on what this law says. So it says that the force of interaction, attraction or in repulsion. I already told you that there are positive charge and negative charge. So if they are positive and negative charge are there, so they will attract each other, because opposite charges attract them. Okay, opposite charges always attract themselves. And if there is negative charge, or positive charge, they will repel, because you know that like charges always repel. So these will repel. Okay. So now, what Coulomb says that uh, the force of interaction, that is attraction or repulsion between any two charges. Okay. Yeah. Just a second. Yeah. So the attraction or repulsion forces between two stationary point charges, meaning that it is applicable for point charges only. It is told here that two stationary point charges in vacuum, they are placed in vacuum, means there is no air or any medium there. So vacuum is directly proportional to the product of the charges, meaning that it is proportional to the product of the charges, and it is inversely proportional to the square of distance between them. So mathematically, electrostatic force between two stationary charges is given by F is equal to K into Q1 Q2 upon R square. Okay. For magnitude, it has written here mod also. So what it says that if you have 2 point charges, only point charges, for point charges it is applicable. So if you have Q1, Q2 two charges, and they are separated by any distance small r, so what is the value of a repulsive or attractive force between them? If these are like charges, so the repulsive force that is acting between them will be equal to K into Q1 multiplied by Q2 upon R square, meaning that it will be proportional to the product of the two charges, and it is inversely proportional to the distance square between the charges. So force is equal to K Q1 Q2 by R square, where K is what? K is the proportionality constant. It is what? Proportionality constant. And in SI unit, K is given as 1 by 4 pi epsilon naught. Okay. So it is a property of medium, and like in vacuum, the medium is vacuum here. So it is the in vacuum, its value is 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay. So remember this value. It is important for you, and it is used in many questions or many problems you face in the future. It is very important to be remembered. where what epsilon naught is what? It is called permittivity of free space. What is called permittivity permittivity of a free space. So remember this also, that it is what permittivity of free space. It is a property of medium, and what is the value of it? 8.85 into 10 to the power minus 12 Coulomb square Newton per meter square. Also, you can remember this value. It is not very much important, but you should know the value. Okay. So Coulomb force acts along the straight line connecting the point of location of the charges, and it is central and symmetrically spherical also. If you have 2 point charges, so Coulomb force will act to the center of these charges, and it will, if it is attractive for positive and negative charge, it will act centrally and in the straight line like this, and is like this. If it is for like charges and repulsive, then it will act away from the center. Okay, so it is denoting what? It is denoting repulsive nature. It is denoting attractive nature. Okay, so what is 1 coulomb? 1 coulomb is the charge that, when placed in at a distance of 1 meter from the another charge of same magnitude in vacuum, experience an electric force of repulsion of magnitude 9 into 10 power 9. So it is simple that if you take the value of two charges, that is 1 coulomb, and the distance between them is 1 meter, then the force acting between them will be equal to what? You can see here that it will be equal to K only. So K value is 9 into 10 power 9, and that is why it is written there 9 into 10 power 9 Newton force will be acting between them. So Coulomb is a bigger unit in practice. So generally we use micro Coulomb or milli Coulomb for our practical uses. Okay. So I hope that you got these points, that what is Coulomb law and how to remember this, what are the application of this, and what are the condition for this. So yeah, let's move further. So till now we have learnt about the absolute uh, like uh, what is the permittivity of free space. Now we will see that what is absolute permittivity of medium. That was for vacuum free space, but now we will see that what is the absolute permittivity of medium. So let's see that what is it. Suppose that the force between two charges Q1 Q2 located as distance are apart in a medium may be expressed. Okay, so if a medium is there, F medium, so what is the force acting is 1 by 4 pi, not epsilon naught here. Here epsilon is the property of medium in which you have placed it. So epsilon will be there, and Q1 Q2 is also there upon R square. So it is what? It is absolute permittivity of medium, not free space, but it is of medium. What is the absolute permittivity of free space? It is epsilon naught. Okay. So we will now generate a result like a relation between F vac like epsilon naught and epsilon. We will see the relationship between them. So F vacuum upon F medium is what? We can write it like 1 1 by 4 pi epsilon naught Q1 Q2 upon R square upon 1 by 4 pi epsilon Q1 Q2 by R square. So it is equal to epsilon upon epsilon naught. You can see here also that it is equal to epsilon by epsilon naught. The ratio epsilon by epsilon naught is denoted by epsilon R. which is called what? Relative permittivity of the medium, with respect to vacuum, because the ratio is uh, permittivity of you can say that permittivity of the medium upon permittivity of the vacuum. So that is why it is called what? Relative permittivity. Like you have learned about relative density. Okay, so that is similar to that relative permittivity of medium with respect to vacuum. And it is noted by K also. K is what? Epsilon upon epsilon naught. And it is called dielectric constant. Okay, dielectric constant. So I hope that you got some idea of what is dielectric constant and what is permittivity, absolute permittivity of free space and of medium. So now we will see that what is the Coulomb's law in vectorial form. Okay, so let's start and see that what is this Coulomb's law in vector form. So till now we have seen that what is Coulomb's law in like scalar form. We have only seen the magnitude of Coulomb's law when we have just derived the relationship before I was telling in the previous topic. But now we will see that what is Coulomb's law in the vector form. So let's start this topic. Okay. Yeah. Consider two like charges Q1, Q2 present at points A and B. Okay, if I have two like charges, not unlike like charges, so A and B are the points where I have to see the charges. So in a vacuum, their distance between them is small r. Okay, so okay, yes. So Coulomb law in vector form is what? If I have like A and B two points, and I have charges, like distance between them is small r, and forces acting between the charges are placed at A and B are Q1 and Q2. The force will act like on Q1 it will act F12, meaning that it F12 is what? That is force on one due to two. Force on one charge to one charge due to Q2 charge. And for this, because these are like charges, so force will act outwards to the direction like centers. It will act outward direction to from the center, and it is what F21. It is F21. If it is F12, then it is F21. Okay. So the magnitude of F12 and F21 must be equal, because this is the force acting on charge, like they have like combinedly acting on both the charges. So if I have like Q1 and Q2 test here, so whatever the force is acting by this charge on this, similar force will act on this also. It is obvious. Okay. So I here it is written F12 is equal to F21, and what is the value of that? 1 by 4 pi epsilon naught Q1 by Q2 by R square. Okay. And for vector form, I have to write the direction also with the magnitude. This is only magnitude of the force acting between them. But if I have to write the direction also, I will place here the unit vector. You already know that. Uh, if you don't know, I will tell you the like next class, that if you have learned about vectors, if I have like 3, 4, 5 like this numbers are there, it is only showing magnitude. But if I add there 3 I cap, like unit vector, I will add here, it will show me a vectorial form with direction. Okay, meaning 3 is here magnitude and I is showing direction. what is x direction. Similarly, for this magnitude of like force, I must add there a unit vector, that is r21 is here. So it will show what? It will show there that this is acting in a particular direction. This force is acting in a particular direction, and it is like R21 for F12 force, and for F21 force it will be like R12 unit vector. Okay. So yes, uh, just a second. I will erase whatever I have done here. Yeah. So we can infer from there that R12 is equal to minus of R21, because both are denoting unit directions, but one is from first charge to second charge direction, and the other direction is from second to first charge. Okay, so these are opposite in direction, so that is why I have added minus sign. Okay, I hope you got this. So yes. So if I got here, like in your NCERT, it is also written like this, that force is equal to 1 by 4 or K Q1 Q2 by R cube. Okay, and like R cube is here, and it is here all like this R vector. So why it is written like this? Because I have added here unit vector. That is why the vector form is like this. I will explain it why. See, the magnitude is only k q1 q2 upon r square. But if you multiply it with unit vector, so it will be r vector, in vector, and k q1 q2 by r square, and unit vector you can write as what? R vector upon magnitude of that. So r or and r square will combine and form k1 k q1 q2 by r cube into r vector. That is why it is written like this in your NCERT also. So you don't confuse here. Only the unit vector is being expanded here and written like this. So this is another form of like vectorial form of uh, Coulomb's law. Okay. So till now we have learned many things for this chapter, from this chapter, like what are the charges, what is the property of charges, and what is the difference between charges and mass, and Coulomb's law we have learned, method of charging also we have learned. So we will see that what is the difference between Coulomb's law and gravitational law. Okay, so if you have before this chapter in 11th class, if you have learned about what is gravitational force. So gravitational force is only of attractive in nature kind. Okay. But Coulomb law is what? It can be positive, like can be attractive also and repulsive also. This is the basic difference between like Coulomb's law and gravitational law. Okay. And similarity is that the force is written in like gravitational law. You have the force is equal to g m1 m2 by r square. It is you can observe that it is analogous to f equal to k q1 q2 by r square. Here g is replaced by k, m1 is replaced by q1, m2 is replaced by q2, and r square is similar to r square. So the both the forces are like similar to each other, but the difference is that gravitational force is only attractive in nature, but your like Coulomb's law or electrostatic forces attractive as well as repulsive in nature. Okay. So I hope that whatever I have told, or whatever I taught you today, you got that very well. And we will see the next things in the next class, because today some time foundation are there. So I will take some problems also in the next class, and whatever is remaining in the theory part, we will see that also. I hope that you all got this lecture very fruitful for yourself. And if you have any doubt, or you want to be taken any private or one-to-one lecture from us, you can contact with us or comment whatever you need. So till now, we will wrap up this session, and thank you and have a good day.